I want to welcome everybody to the second in the series of talks on AI and the humanities. These seminars are sponsored by the Northern Plains Ethics Institute, the School of Humanities, the College of Arts and Sciences, Dakota Digital Review, or Dakota Digital Academy, and Tri-College University. Sorry, there's a list, I didn't have them all here. Today we have Denton, a professor at NPEI's Department of Computer Science, to give us a talk about something she's been working on for quite some time. Denton is a professor, and she received her PhD in physics from Johannes Gutenberg University in Mainz, Germany in 1996, and an MS in computer science from NPEI in 2003. Research and data mining of complex data has been motivated by applications in genome mapping, remote sensing of agricultural fields, and among many others. Currently, her work focuses on geospatial and ethics-related questions. Den has published more than 80 peer-reviewed journal and conference publications, has led projects funded at a total of more than $1 million. So, for those of you who are unfamiliar with how the NPEI operates, she presents, then we'll have time at the end for questions from both the people here and the people online. And our view, if you didn't realize, with the Northern Plains Ethics Institute, we ask two questions: what kind of society do we want to be? And then how do we get there? This is all about civil conversations designed as constructive to develop ideas more than anything else. So we welcome you to participate in that conversation. Let's welcome our speaker.
AI has taken the world by storm, and there are technical aspects to that are not very broadly understood. And in order to understand the ethics implications, I think it is important to have just a very general sense of what the technical side is, because AI isn't AI. There are some details that matter because they're not details at all. So forward. So the picture that we have in mind for generative AI is the first ones, the ones last fall, were these kinds of pictures. This is a image that won the first place at the Colorado State Fair. The New York Times reported on this, and it was created by Midjourney. I believe it was Midjourney, not DALL-E. There are two big ones, Midjourney, DALL-E, that use the same kind of learning mechanisms that ChatGPT, which is even more in everybody's mouth now, uses. And I mean, when you look at that picture, it really, I mean, it's a very far beyond what artificially created AI could do previously. You could forward. So ChatGPT is the text version of this kind of technology. It can answer questions that we haven't even remotely been able to let AI answer. I did, most of you have, who has heard the term Turing test? About half. So Turing test is when can AI no longer be distinguished as a respondent. So somebody communicates with an entity, doesn't know if it's a human or an AI. And if they cannot tell which it is, then that's by Alan Turing's with arguably the most well-known computer scientist. And if you can no longer distinguish that, you've reached an actual artificial intelligence. I try this out by giving students the task to come up with a question, answer it themselves, give it to ChatGPT, give me both answers, and then I created a quiz and let students answer the questions of the other students. And it was basically not distinguishable. They couldn't, they were wrong approximately half the time. This is a huge problem for online exams. It's arguably really world-changing. A lot of people view it as world-changing. Meanwhile, there have been jokes that ChatGPT couldn't play chess. Now that seems to have gotten better with the new version. I'm not a chess expert, so eventually I decided going again with not going a chess example. Instead, I went. So now here you have it: 12,821,088,480. So it gives you this answer that looks amazingly exact. I mean, even you could even argue the 480 here, 240, that this must really be highly intelligent, yet it is off by a factor of 3 for a basic multiplication that at least those our age would still be able to do with paper and pencil fairly easily, right? I mean, you just multiply the first two, multiply by the next, and multiply the next. I mean, I think, I don't know how the younger generation still practices those skills, but I'm sure that people our age would be able to do this in 5 minutes, no problem. With the title of this talk, Artist or Geek, I'm trying to make the argument that any one of us, I want to be very clear, this is not about the artists there and the geeks there, but it is about sort of the artist and geek in every one of us. And there is a TED Talk that really influenced me 15 years ago when it came out, was by Jill Bolte Taylor, who wrote a book. So she wrote the book 15 years ago, so it's probably events that happened 20 years ago. So she, as a brain scientist, experienced a stroke. And later, after she recovered, she wrote a book about that experience, because as a brain scientist, she could, even at the time, figure out what was going on. And that helped her get help, because it's a fascinating book. Anybody who knows anybody with a stroke, I highly recommend it. For the purpose of this talk, the TED Talk is fine. In fact, the whole TED, even just listening to the TED Talk is very interesting, but we are only going to be listening to a short piece.
If you've ever seen a human brain, it's obvious that the two hemispheres are completely separate from one another. And I have brought for you a real human brain. Thank you. So this is a real human brain. This is the front of the brain, the back of the brain with the spinal cord hanging down. And this is how it would be positioned inside of my head. And when you look at the brain, it's obvious that the two cerebral cortices are completely separate from one another. For those of you who understand computers, our right hemisphere functions like a parallel processor, while our left hemisphere functions like a serial processor. The two hemispheres do communicate with one another through the corpus callosum, which is made up of some 300 million axonal fibers. But other than that, the two hemispheres are completely separate. Because they process information differently, each of our hemispheres think about different things, they care about different things, and dare I say, they have very different personalities.
So the idea is that they're really inside any of our brains, there are these multiple personalities. And we'll see there are multiple ways of, I mean, this parallel processor versus serial processor. In the world of AI, and really, I mean, artificial intelligence is what this is about. What I think is the more common way to talk about this is the symbolic versus neural network. And we'll see another clip about that in a moment, but just to get you an idea of what that distinction is. A lot of the early AI was about symbolic reasoning. If Alice is a parent of Bob, and Bob is a parent of Chris, and you ask, well, and you know that a grandparent is a parent of a parent, and you ask who are the grandparents of Chris, then that sort of old-fashioned AI, could you just forward one? That old-fashioned AI would be able to reason that Alice is a grandparent of Chris. This is what logic reasoning is about. And by the way, there's not just computer scientists who deal with this. Every so often, I will have a student coming into my office and being completely surprised that what philosophers teach as symbolic logic is what we teach as Boolean algebra, and they will think they have reinvented some great parallel that they never knew about. So I mean, this is what logic is, and whether you when you're talking about philosophy, it would be symbolic logic. If you're talking about computer science, this would be a Prolog program that would calculate this for you. This is quite different from what neural networks do. So neural networks were built to be more like our brain, more the way sort of our brain is implemented. They have multiple layers. The traditional ones only had 3 layers. There was some proof that under certain conditions that was really all that would produce different results. The new ones, they are deep neural networks. They've got a lot more layers and they work slightly different from the original ones. And this is a very different model. So, I mean, with this one here, you've got symbols and you manipulate the symbols. With that one, you really try to simulate sort of what's going on in our brain. And if you could go forward, you may have heard of Geoffrey Hinton. Geoffrey Hinton had recently left Google. He's sort of viewed as the godfather of AI. And he explains something that is pretty similar to what Jill Bolte-Taylor explained. So if you could show that clip.
At the time when you entered the field, there were 2 schools of thought in machine intelligence, mainstream and neural nets. Can you describe the difference between these two approaches?
I can sort of caricature it. So there's 2 different models of what intelligence is all about. And one model is that it's all about reasoning. And the way we reason is by using logic. And so that's what's special about people. And what we should be doing is understanding the kind of logic that we actually use. And that also went with the idea that the knowledge you store is symbolic expressions, so that I can say a sentence to you and you will somehow store that, and then later you'll be able to use it for inferring other sentences. But what's inside your head is something a bit like sentences, but cleaned up. And there's a completely different model of intelligence, which is that it's all about learning the connection strengths in a network of brain cells. And what it's good for is things like perception and motor control, not for reasoning. That reasoning came much, much later, and we're not very good at it. You don't learn to do it till you're quite old. And so reasoning is actually a very bad model of biological intelligence. Biological intelligence is about things like controlling your body and seeing things. And that was a totally different paradigm and had a different idea of what's inside your head. That it's not stored strings of symbols, it's just connection strengths. The symbolic AI view, the crucial question was, what is the form of these symbolic expressions and how do you do the reasoning with them?
So again, a very nice TED Talk that I highly recommend listening all of it, because it also talks about the risks and that Geoffrey Denton is really afraid of. Has basically with ChatGPT has started being concerned about that general AI, the risks that we can lose control to the general AI. Something that, I mean, that's also an important topic in its own right. Next slide, yeah. Again, my goal is to get across that AI isn't AI. There are different things. So how do these 2 relate? I mean, if you read more about brain, there is the language center, which typically is in the left hemisphere. It isn't always, but with most people, the language center is in the left hemisphere. The language center is the one that's responsible for the symbolic reasoning. So it's brain scientists have identified exactly where that is. And I mean, of course, it also is implemented as a some type of neural network, just because that's the only biology we have. So it's not fundamentally impossible to for a neural network to reinvent the reasoning, but we do have to be aware that it's not terribly good at it. And when it gets those multiplications wrong and so on, it's because that was not what it was designed to do, and it makes mistakes with that. Another scientific way of talking about these things comes from economics. Daniel Kahneman was a Nobel laureate. He got the Nobel Prize for Economics in 2002 on work that distinguishes what he calls System 1 and System 2. And it is usually, so even the people who have been discussing the generative AI, so where is ChatGPT on that spectrum? I've listened to some presentations where they say, well, ChatGPT can do System 1 things, it can do a little bit of the System 2, but it's not very good. So that's how people talk about this. This kind of language is our educational, STEM education people work with this language. The System 1 versus System 2, especially since this book came out, has entered sort of the common way of talking about things in areas that talk about, are we really reasoning this through, or do we just let our intuition? So basically, System 1 is our intuitive thinking. So the first thing that we think of when we get a question, it's the quick response, and it can be really good, right? I mean, our intuition can be really good, but sometimes on logic puzzles and things like that, once we do the reasoning through, we'll realize, oh wait, the intuition wasn't quite right. And yeah, I mean, just as much as our intuition can be wrong, ChatGPT can be wrong. It's that there is a lot of parallels to this, because the intuition does not guarantee logic consistency. Please. Oh no, we don't need that. Sorry, no, you can keep going. Yeah, this was just a talk that made that statement about that comparing ChatGPT with that System 1 versus System 2. So I mean, it's important always not to just oversimplify, overstate. I mean, AI models never work exactly like the brain. We don't fully understand everything in the brain. We don't even really necessarily understand why ChatGPT draws particular conclusions. Just because something is neural network based doesn't mean that it reasons like an artist. I mean, for 30 years, 40 years, we've been using that neural network just to answer yes/no questions that wasn't at all what the generative AI is about. And also, I mean, even regular logic computation can lead to beautiful images. So what you're seeing on the right there is fractals. It's completely mathematically derived, nothing like ChatGPT. And I mean, I think it looks cool too. So I'm not trying to come up here with oversimplifications. What I'm trying to get is, we can't completely ignore the algorithmic choices when we're discussing AI. Next slide, please. So what are algorithmic choices? What is an algorithm? The thing that I have said this so many times, and it's not even usually in the introduction to computer science, but it's usually when collaborating with genomics people who would tell me, well, oh, these algorithms keep getting things wrong. And I explain to them, well, the people who wrote the program did what you told them. Maybe you didn't tell them right, because I mean, what an algorithm is, it's an algorithm is defined by what is acceptable as its input and what is expected as its output. And until we really have nailed that down, we can't get to how we're actually implementing this. And there are choices with how we implement things. And I will go through those, and I'll try to keep that somewhat brief because it gets a little bit technical, but I just want to be sure that people understand that there are choices when you create an algorithm. So next slide. So one of the choices is, I mean, is everything pre-programmed? And I mean, the first AIs were pre-programmed. I mean, and they were called expert systems. They encoded the knowledge of experts. The ELIZA chatbot, I actually remember a friend of mine in high school found the ELIZA bot in a computing magazine and typed off the entire code from that magazine, and then it could answer questions. And you might not see those. The main thing I remember is that if it didn't know what to make of a word, it would say, "Could you tell me more about that word?" I mean, can you distinguish this really from a person? So people were really wowed by that, but there is nothing unpredictable in this. You could go through the code and you would always know exactly what the answer would be. But that's not what most current AI is. And I mean, well, except, I guess, military applications. And last time the chancellor talked about military applications. So in military, a lot of military AI still, I think now that's not usually called AI because it really is completely deterministic. Immediately see what happens. But I mean, just as an example of what's not deterministic, you may know these predictive text poetry, that if you start with a sentence and then you always click the middle suggestion. And I tried that here with Artist or Geek, and it gets sort of silly, but what makes this interesting is that each of us gets different text because the predictive system does use information about the person. It's probabilistic. We can never be completely sure what somebody else will get because we don't know what they normally type. And most AI is in some form like this. So probably pre-programmed, deterministic versus probabilistic. Next one. This is getting really technical. Does it just use a few pieces of information, or does it just take all of the information? All the attributes about something. If you take, I mean, if any one of us is just defined by, let's say, even just 1,000 different pieces of information, if you build something in this, what computer scientists call a 1,000-dimensional space, it's difficult to understand what's going on. And again, technical difference. And again, of course, ChatGPT, generative AI is on this side of using lots and lots and lots of information. Next slide. Explainable. So an explainable doesn't, it's not the same as is it probabilistic. If you purchase something, Amazon, wherever, you often see these people who purchase this particular item also like this. And that helps you know why you're getting the recommendation. And if you only got this one book for a nephew who you only give a book to every 5 years, you know you don't need to look at that recommendation. It's actually, I think, surprising how much advertising does give you that explanation, because they know that if they just say, here's something you may like, how do you know? So the explainability is really big, but the problem is ChatGPT and also any deep neural networks are not explainable, and there are people who have abused this. And I mean, what are you seeing there? Are you seeing here an airliner? Probably not. Yet people have been able to train deep neural networks to see an airliner here. And if you realize that this is technology that's making it into autonomous vehicles, ouch. So any of the new AI is not explainable. That does not mean that AI cannot be explainable. It just means you can fool it. So how does this work? It works by training, so always rewarding it for recognizing whatever you want to recognize, even if a human would totally not recognize that. So it's a vulnerability of a lot of the deep neural networks. So even the not just the generative ones, but the even the deep neural networks that are underlying a lot of technology. This is a risk that I don't know if how much really the public is aware of this. Next one. There's another thing that sort of happened to text-based analysis. You may have, well, those are that's old enough. In the 1990s, there was the expectation that AI would be able to translate grammars and translate languages. And the idea was, well, it would figure out what the grammar of the sentence is, would take the grammar, and then it would construct a sentence in the other language. And that just failed so. I mean, it was always just next year, 2 years, 5 years. It never happened because that's not how language works. One example of why that doesn't work, my mother-in-law noticed a sign in Prague once that offered chicken chests. Somebody had a little bit trouble with the English language. So we do a lot of things by just common word sequences. And you just hear that's not a common word sequence. There's something wrong there. So the breakthrough in both machine translation, search, and so on was when Google also, of course, used the network structure. I won't go into that, but in general, since about 2000, Google has mostly just worked with word sequences and not cared about the grammar. And that works well for predicting, for creating text that sounds nice. But be aware, when you're using word sequence-based AI, that AI cannot distinguish the sentence. I mean, time flies like an arrow versus fruit flies like a banana. The sentences look similar, but in this case, flies is the verb. In this case, like is the word. This is an example that Steven Pinker gives in his book, The Language Instinct. I think even at that time he didn't invent it. It's been used as an example for what grammar matters. But I mean, why am I talking about this? Well, the reason I'm talking about this is when ChatGPT gives you nice stories, ChatGPT doesn't know the difference between these two. It just knows where they sort of fit in typical conversation. Curated input, I mean, for years, just because of the machine constraints, people couldn't, oh dear, I'm too slow here. You could just use limited data sets, curated and so on. ChatGPT doesn't, it reinvents every gender bias and whatnot, just because, and this even, we can't even really counteract it. It reflects the biases in society, but there is no systematic way to counteract it because it just sucks in everything. References, that's been discussed a lot, of course. I mean, it makes up references. Google always tried very hard here, give you the, for when I search for references produced by generative AI, it gives me the peer-reviewed publications. It does give me an answer here, but it tells me the answer is directly from here. So you can see whether you trust that reference, whether it really said this, whether it was taken out of context, all of that. ChatGPT doesn't do any of that. It's from a scientific perspective, a total disaster. All of the things I discussed that were all sort of independent things, but ChatGPT is always on the unreliable side. So just be aware of that. I have played around with ChatGPT from the beginning. One of the things I like to ask is when is an equation that is true in a particular number system, but not in decimal. So 2 plus 2 plus 2 equals 1, 2. That's true. As the number systems work, you get to a certain point and then it flips over. Like with decimal, you get to 9 and then it flips over to 10. With base 4, it goes to 3 and then 4 is 1, 0. So 2 plus 2 plus 2 is 6. So that's equal to 1, 0 when in a base 4 system, you go up to 3, then 4 is 1, 0, 5 is 1, 1, and 6 is 1, 2. Keep in mind, this is totally smack dab in the expertise of every single person who programs ChatGPT. So I'm really taking it on with a question that everybody who programs, you might not know the answer, but the people who program ChatGPT know the answer to this. Everybody. What does it answer? The equation 2 plus 2 plus 2 equals 1, 2 is true in base 6 arithmetic. So it does understand it's the question of the number system, but why does it say base 6 when I just explained to you that it's base 4? Well, in base 6 arithmetic, 2 base 6 plus 2 base 6 is 4 base 6, correct. 4 base 6 plus 2 base 6 is 1, 0 base 6. So it already tells me we now have added 2 plus 2 plus 2, and it tells me that in base 6, this is 1, 0. Well, but I asked 1, 1, 2. So it already tells me that the answer is not correct, but it just adds another 2. So it now has, it gives me the answer for 2 plus 2 plus 2 plus 2. And I mean, this to you may seem, well, this is sort of arbitrary, why bother about this? But this is how I feel when I'm sitting next to a student where I'm really wondering, oh, is this student going to make it in computer science? I mean, look, you have obviously even listened to everything that was said in class, but you didn't notice that you added this number 4 times rather than 3 times. What am I supposed to say? This is just such a trivial mistake. Don't you see where the issue is? And I mean, this is how a lot of computer scientists feel with ChatGPT answers that involve reasoning. It's just, it's using all the right words, but it just, the things that should be really, really simple to just really count how many times you've added something, doesn't do. Next slide. And this is sort of this actually my cousin did a study on he's working with physics education, and he asked the question, and this was still the old ChatGPT, but so the early, what I showed was ChatGPT 4. It's the newest one. This was the older one, and he tried to find out whether it could pass a introductory physics class, and he had to check. He had to assume that it would ask a tutor. And with the help of a tutor, it would just very barely pass it. But I mean, really great C or so, not well. Next. And I mean, yeah, keep in mind, my cousin actually developed software that checks, that gives quizzes that depend on the numbers. The actual computations that are necessary are trivial in a computer. So it's getting this wrong, despite the fact that the answers would technically be trivial. So going back to how we started, you can argue, well, okay, so maybe the left side of the brain is the one, the conventional AI, and maybe we just need to create that corpus callosum. And yes, I mean, this is not just hypothetical. This has already been done. So you can already get the newest version of ChatGPT with a Wolfram Alpha and Wolfram language plugin, which would solve at least some of the, I mean, at least the multiplication it surely would solve. It probably would also solve the other one because it would probably plug it back in and check whether the answer is even plausible. Next slide. So dependability is one problem, and I think it's a serious one, and it's one that creates issues indirectly. But there are, of course, all sorts of other issues. Ownership of intellectual property, and this is basically the outline of the remainder. Empathy, laws of robotics is about losing control, funding, financial incentives, and yeah. So if you could just proceed. So I'll have one slide about each of these. I won't spend time now on this. Intellectual property is, of course, a huge issue that artists in Hollywood immediately saw. If these are trained on existing artwork and text, but the original people don't get the credit. And I mean, the thing to keep in mind for specialized topics, it may just really be a small number of work. And I mean, humans do that too, of course. They imitate what other people have done, but they get called on out on it too, right? I mean, if somebody gives a presentation and really copies somebody else, they get called out on it. Why don't we call out AI as much as we call out humans? And the stuff was sourced without consent. Next slide. Oh, yeah, and by the way, my students already brought this up in the fall of 2022. So before ChatGPT even came out, there were artists who were among my computer science students who were quite upset at that. The issue of empathy, I am not very optimistic, because the thing to keep in mind, intelligence does not tell us about whether a system can feel pain. I mean, and I don't think, I mean, there are people who sort of now say, well, because the AI is now responding intelligently, maybe it feels something. But our pain is processed, the processing is deeply related to our brainstem. We haven't even tried to really reproduce that. So I think it's fair to assume that AI does not feel pain, joy, experience a sense of meaning or anything like that. There is another issue to this. I mean, you could, of course, train for this is painful. You could encode this is painful, don't do it, but that would then depend on reasoning. Empathy is reasoning about the perspective of the other side. We just saw that ChatGPT can't reason. So if it can't reason about empathy either. So and this is where I'm saying the problem with the reasoning, it does feed back right away into whether we can expect that an AI will show empathy and just respond appropriately to somebody else's pain. Next one. The risks of losing control to a general AI, probably the most famous sort of alert of that goes back to Isaac Asimov's a short story he read in 1942 already. And he came up with these rules that said a robot may not injure a human being, and so on. Well, you can read them yourself. You can look them up. They are cited a lot. The problem, of course, is we are already arming drones and other autonomous beings, which means sort of we are already giving AIs the capability of harming human beings. And in fact, I thought it was actually funny. This was something that my students pointed out this class in the class that we already. Yeah, so a couple of the slides were actually motivated by something where students already saw this very early on. So the good thing is computer scientists do think about these things. Next slide. So what are the risks? And I'll be honest with you, the problem with, I cannot tell you what the risks are. And I cannot tell you for the reason that there is very little work on this. The National Science Foundation cares about ethics. It cares about ethics in the research, but not about the ethics of what eventually comes out. Even fairness in AI, which is clearly an ethics in AI topic, it was funded 1 year together with Amazon and then not anymore. NSF recently got more funding, but it all went into industry partnerships. So then it depends on, does the industry really want to hear any bad news? Yes, generative AI is discussed. There was some email, I tried to find it, but as I recall it, a program officer sent the email where he talked about allotment and made this joke that generative AI is in everything, everywhere, all at once. Probably heard that movie title. So it's, yes, I mean, NSF cares about generative AI, but there's no big change in thinking. Next slide. So, I mean, could we even talk about ethics? And the first thing to realize is that the National Science Foundation is about science. Is ethics a science topic? And no, it's not, because there is a difference between what is and what ought to be. I've talked about that in other presentations, and I mean, the ethics instruction talks a lot about this. It's basically if you only start out with facts and you only do logical reasoning, like the prologue example I gave, you'll never get anything that says this is good, because if you didn't start out with statements about good, where would they come from? But there are all sorts of other differences. That ethics is a subject of the humanities. They operate differently. Different frameworks can produce different results, and that's accepted as normal. In sciences, it's not. Analyses don't typically fit the yes/no mindset well, and the problems are too complex, and then there are the feedback loops. If I say something, it might affect something later. So there are lots of differences, but they don't really distract from the fact that none of us want AI to take control, and the people who program the AI know a lot of things about that nobody else can really replace. Manipulation, same thing. I mean, if you develop an AI that can be manipulative, that's the people who develop it have to be part of the solution. AI-enabled weapons is a whole other thing. And I mean, also, sort of my the thing I like is that there's some aspects of ethics actually that you can relate to science. So yes, I think this is a topic where science and philosophy have to work together more closely. But I also think it's important to realize that unless there is funding for things where bad news is an acceptable thing to talk about, just saying you need to work together, it's just sort of shifting blame. Next slide. And I mean, one of the things to realize too is while scientists claim to be objective, that does not necessarily preclude scientists from arguing against science. One person who has for a long career stood up and really analyzed the cases where scientists support unscientific statements is Naomi Oreskes. She actually was at Valley City State last week. She was at Zambros Variety in Fargo on Tuesday, and then Valley City State on Wednesday. I can't believe we didn't invite her. I don't know how that happened. She is very well known, extremely good speaker. So we did go to the Zandbras event, which was just supposed to be a book signing, but she let people ask questions. And then for 2 hours, she just very eloquently talked about these things. It was mostly about her very a book that has been out for a long time, 2011, The Merchants of Doubt, which is about this specifically. She has had newer books that she was talking about in Valley City State. She talked about one about science. If you don't know that book, read it. It's scary, but I mean, it's just to say, just because somebody is a scientist does not necessarily mean they support the science, which does not help with getting to the bottom of risks. Next slide. Well, actually, that was a time scale matters too. I mean, in the short term, it can help to not care about the long-term science. There is a more complicated problem, and this is sort of more where my own interest is, that scientists don't have to explicitly contradict science to do something unscientific, because while there are scientific methods about gaining answers, there are no scientific methods to figuring out what question we should ask. It's sort of the Hitchhiker's Guide to the Galaxy thing, where the big computer came back after many years with the answer 42. I'm sure you this was basically playing on this, that yeah, finding the question may be a lot harder than finding the answer. The questions are steered by funding, by solicitations for funding, and that's why I put in that NSF slide earlier, because I mean, if there is no question for checking what could be the bad news, then there won't be any answers about what could be the bad news. Why is that? Well, the National Science Foundation has to defend priorities to Congress, otherwise their budget gets cut. So Geoffrey Hinton, who we saw earlier, he left Google because he felt that if he was working with a company, he could not freely talk about these risks. And he made very clear it was not specifically that he thought Google was doing something wrong. He thinks everybody is doing something wrong, but to say that, he can't be working for a company. And I mean, honestly, I mean, being funded by the National Science Foundation isn't much better, because I mean, there too, you have to be careful with those really bad news stories. And I mean, he later in the same clip that we saw, he explicitly said this, and you'll see it's 99 people are working on making them better, and 1 person is working on preventing them from getting out of control. And this, I think, is the problem. I mean, we can try to shift the blame to not enough ethics, whatever else, but I mean, if we are funding, if 99 times as much funding goes to making the AI advance fast and then to keeping it under control, that 1% cannot keep up. And I mean, again, this applies to academic researchers. Next slide. Yeah, so this is the last slide. Okay, I went over time, sorry. Yeah, so we don't know the risks until we study them. There is the sense that it's bad for business if we have this negative story. But I mean, if we don't study the risks, that's not necessarily better for businesses either. I mean, I find it sort of amusing when you see people say that the climate policies have pushed so much money to China. Well, why have the climate policies pushed so much money to China? It's because maybe, at least partially, because China has accepted climate change as happening, and American businesses don't have the products that would deal with reality of forest fires in Canada that are obscuring the sun now already. So I mean, business friendly is effectively very often, well, we accept that we're only looking at a 3-year time frame. Business not friendly is look at a 10-year time frame. I mean, that's what a lot of the difference boils down to. And whether or not one of the topics that came up in the last presentation was the regulation, how expensive it is to satisfy regulation, and Europe has been more proactive on regulation. So the GDPR was one topic that was discussed there, which is regulation in Europe for protecting people's privacy. One of the things, so I know people who have had to bring NDSU and Microsoft code up to speed on the GDPR when it first came out. And one of the things that is hardest is the right to be forgotten. So that's an example of a place where ethics makes things more expensive. Well, but it's also an example of you don't need the GDPR to have people who go up the wall for their data not getting deleted. And I mean, that's been an issue with in lots of other contexts, like when Uber kept monitoring people after they deleted the app. So it doesn't take, with any good regulation, ignoring it will probably cause other problems no matter what, because again, I think it's really a question of eventually the long-term future will happen, and eventually a lot of the question is, do we accept that we need to be prepared for it? Are we willing to pay for the things that we need to understand in order to be prepared for it?
Thank you. I can get this microphone out, which I can. Okay, so what we'll do is ask questions. Can you see online? In case there are questions.
Oh, by the way,
So
when I said things, sorry for interrupting again, but when I said I do things in my writing, that there is a URL here where there's some more of my sort of advertising on my anyway.
so
Sorry.
we're ready for questions now. We'll go back here, and Tyler will be watching for online questions as well.
Sorry. You mentioned studying for risks for AI. What would that look like?
Well, I mean, with any of the things, you would just set a problem statement. So what, take a particular AI, let's say ChatGPT. I mean, what is the risk that ChatGPT will give poor advice? Well, there have been examples. Somebody asks ChatGPT for a say marathon training advice or so. So I mean, you would, and I mean at some level, of course, they're doing it at the level of, is it giving poor advice? But you could try to become more general. What kind of checks do we need to implement that this is not just, it doesn't just have to be fixed on a one-on-one matter way, but that in general there is accountability for the answers. The ones that Jeffrey Hinton is mostly talking about is just really completely losing control. That in itself is, and that's maybe the most obvious one. I mean, what are the actual routes through which humanity as a whole could lose control to robots? What do we need to implement that doesn't happen? What manipulation is and propaganda kinds of problems are huge. And I mean, to the extent that it affects the United States, there are people who stand up for not having political propaganda distort elections. But again, I think distorting of elections, that's not a specific ChatGPT problem entirely. I mean, that was a problem already before, but it would have a lot of new aspects now with generative AI. With that, but with the interference with elections, there are plenty of places around the world where we're not nearly putting the emphasis on. So if I were to, what would be my first one to study? I mean, I think the first one to study is where have social media and generative AI already disrupted international the politics in other countries, and the more we would look into this, how can we create well, guardrails is often used as the terminology. I think guardrails is it's one aspect, but the other aspect is where can we create check things that involve reasoning? Where can we so my own writing is about this concept of paradoxes. So paradox is something that is cannot be consistently answered. So I could go off on a long tangent, you know, but a paradox is for example, well, the most basic one is this sentence is false. However you think about it, you cannot. Okay, so you can't do anything about that one, but there are others like the Achilles and the tortoise. Say you give a tortoise 100 feet head start, and the fast runner tries to catch up with it. Well, but by the time the fast runner has reached the tortoise is already a little bit further ahead. This one was Zeno, I forget the time, but I mean, more than 2,000 years ago. So you can have this argument, well, the fast runner can never reach the tortoise. That one took a couple of thousand years before it got resolved through calculus. So this is sort of what I wish we did was to look at where AI, and I mean, there are other things in related to climate and so on, where do we get basically paradoxical answers, things that don't match up, and really study what's causing this and what is the theory that, what is the frame of mind that will, or the technology that will reestablish consistency. And so with the Zeno's paradox, it took a couple of thousand years. That paradox did not prompt the development of calculus, but there's some theory of relativity was, well, I mean, if you've got a spaceship going at, if you know you cannot exceed speed of light, you've got a spaceship going at 90% of speed of light this way and one at this way, well, the person sitting on this one will see this one go at faster than speed of light. How can that be? Only way to reason was theory of relativity. So, I mean, these kinds of paradoxes allow us to, they prompt new theories. And I mean, so the reason I'm, so you'd really need, if we want to prevent the bad things from happening, we have to just see what we don't want to get. Where are we getting things that are really inconsistent, that can't work out in the long term? And then it's going to take a lot of people to look at this with different perspectives and figure out how can we fundamentally. So maybe the single. But if you wanted to say, let's say empathy. So how can we guarantee that the reasoning that so that a robot that is supposed to understand emotions of the other side, how can we guarantee that it will not make a severe error in reasoning? And that would be maybe so based on the scope of this presentation, which is not the only scope of what I'm looking at, but I mean, based on the scope of this presentation, the first thing I think I would want to see is, can we develop a reasoning framework that will ensure that in AI that reasons about empathy, somebody else's pain, that it will not go off the rails?
We have a question online.
In the chat from Ganopathy, we have the speed of systems such as Chat GPT is a smokescreen if critiqued. The language processed by Chat GPT is startling and accurate in terms of how humans do it. Do we discount systems such as Chat GPT because they are fast?
I'm not sure. I mean, the observing that they don't have a fully functioning system too was part of the presentation. So if I understand correctly, the question is, do we give this more? Do we give ChatGPT more credence than we should, or I'm not sure. I mean, there are other systems that don't have the same shortcomings. That's what I try to say in the presentation, that there are other ways to do things. There are ways to connect ChatGPT with other systems, but I guess I'm not fully understanding the discounting, because anyway, so I guess the answer is yes. I totally think that that ChatGPT does not do language the way humans do, and the fact that it cannot reason fully at system 2 level is an indication of that.
Thank you. We do have another one from Ganopathy in the chat here. Most of the AI foundational models capture only certain aspects of creative processes like stable diffusion and image creation. Designers use many layered processes serially or simultaneously when they design. Question: what research must be done in foundational AI models in order to develop AI systems for architectural design processes?
Well, I mean, I think that every subdiscipline is going to now take this AI and adapt it to its own purposes. And I think a lot of what in this question comes out as what's missing is the combination of the symbolic and the neural network reasoning. So there's basically, I mean, again, the summary of the first half of my talk was we basically need a corpus callosum that is optimized at tying in the symbolic ways of reasoning in every one of those disciplines. And I mean, again, this is happening as we speak. As far as ChatGPT for regular kinds of applications, it has already happened, in the sense that all you need to do is to purchase a Wolfram Alpha plugin. So that portion Yes, I think we know roughly what we need to do. Even when looking at the brain, ChatGPT basically is not doing it by itself, and neither are the graphics ones. We do have the two ways of looking at things. We know we have a language center in only one of the parts of our brain, and maybe the left and maybe the right, but there is one language center that does the symbolic processing. We know we need to somehow involve this. Until we really involve the symbolic reasoning, they're going to be unnecessary mistakes. So, I mean, I think that portion, yes, there is a lot to do, but I mean, it really only came out this spring. So, I mean, and well, okay, if we include Midjourney and DALL-E, it's been a few more years, but I mean, that portion, I think there are probably thousands of people who are working on this right now. And I also think they will succeed. We already see them succeed at some level. I don't think that really addresses the concerns entirely because of in no field have we really given enough credence to risks. Well, and I shouldn't say that. There was a field that made a lot of progress when risk was considered. That was the banking system in the 1990s. I actually had or late 80s. A lot of my friends went into the, so I studied physics actually, and a lot of my friends went into the banking sector because the diffusion equations that work in physics suddenly allowed proper numeric risk management, and yeah, they could get rid of a lot of risk, except they were so confident that they'd gotten rid of all the risks that arguably that later resulted in even worse crashes. So that's always one concern. Of course, it can say study more risk, but when we study more risk, it might also make us more tolerant of risk and might actually increase the risks. It's sort of by the same logic that my dad said that of the colleagues who learned how to not get a car spin out of control on ice. All of them had an accident within the next year because they needed to use all of that knowledge about risk. so there are no simple answers. But I think that the message I'm trying to get across is 99% of people seeing everything going great, and 1% seeing, oh, actually things could go terribly wrong too, is an imbalance that is a problem. That's the main message I'm trying to get across.
So I have a question. I'm editor for the Springer's International Library of Bioethics. I just commissioned a book, or just contracted a book. A woman who is African-American, Black person, talking about AI in healthcare. So she's talking about how AI is affecting minorities in healthcare. And what it does, of course, is it looks at enormous amounts of data, but because you've got people who are minorities in it, their stuff is being skewed in a way that doesn't help their healthcare. And even if you've got somebody programmed, because you need to train AI with people who are creating the data sets, you've got maybe implicit bias there as well simultaneously. So is it actually reasonable to think that AI is going to be able to eliminate bias, that we can even manage it, or is it just going to make it worse for the folks who are underrepresented in the first place?
I can actually objectively answer that question as no, because there are, I actually taught that in spring, the tools that are used for training AI to be fair. And there is no one definition that satisfies everything. So there are 3 definitions of fairness that are all inconsistent with each other. And that sort of goes back to this inconsistency, that it's not a inconsistency that can be fixed. That is a huge problem. And I mean, so I think the slide that I asked to race forward on had some of that. I mean, we have these problems when we have well-curated data sets. Even then, we can't really, there's still 3 different definitions of, at least 3, there are dozens, but 3 that are covered in class, let's put it that way. So, and that were not consistent. And you could not achieve consistency between them. And that's only on the curated data set side. With the generative AI, it's not curated. So to be really honest with you, I think the answer is yes. It will just make matters worse for the people for whom the situation was already bad. I think that is at this point, nobody has convinced me that anything else will be the case.
Thank you.
Questions in the room? Is there anything online?
Is emulating how the brain works the right strategy to develop AI systems for design activities, or is it results-based and driven?
So to be clear, the generative AI is not anymore emulating how the brain works than neural networks of the 70s. The idea that we wanted to emulate how the brain works, that's what led to the development of neural networks. Neural networks then have basically taken on life of their own. I mean, the research in the figurative sense, the research has been based on what works. And I mean, for the longest time, neural networks, it was really about predicting true-false questions. For, I mean, 30 years worth of true-false questions, basically. It's been fairly recently that sort of the concepts of neural networks have gotten changed, and I could get into the details of attention and dropped connections, and there are certain, there were a number of breakthroughs that allowed better results. It's not that the researchers emulated the brain more. It's just that they found that certain things worked that were new, and that has, yeah, I mean, it's result based. I mean, the reason why Midjourney and ChatGPT have had such a huge impact is that the wow effect. and they solve some real problems. And I mean, they solve some real problems in IT. I mean, first week that ChatGPT came out, a colleague found a documentation about how to install a particular router. I mean, it works. So people get out of it what they want. That's why it's been so successful. Images look pleasing if you ignore the 5 fingers, the 6 fingers anyway. But I mean, but aside from minor glitches, it's amazing. There's the wow effect that does solve actual problems. And I mean, we can't distinguish it. I mean, if students in my class could not distinguish whether their colleagues had written a text rather than ChatGPT, I mean, that is amazing. So for that general purpose chatbot feature, that's good. I mean, sure, people have put the most emphasis on the things that benefit the most people. Architecture is probably not among them, but yeah, the more people now will put attention on those matters, those problems will get solved. What the side effects are going to be is a different question.
Well, I want to thank you for a really informative talk and the beginning of a interesting set of questions and conversations. This, as you might know, is being recorded. It'll be edited and then uploaded to the Northern Plains Ethics Institute YouTube channel. I want to thank our sponsors again. They are the College of Arts and Sciences, the School of Humanities, the Northern Plains Ethics Institute, Digital Dakota Academy, and then finally Tri-College University. And big thanks to Ann Denton for doing such an amazing talk today. Let's thank our speaker. Next talk will be on October 24th. The superintendent of Fargo School Districts, Dr. Gandhi, will be talking about ethical issues in education, including ChatGPT. So we welcome you. Look for us on our website. And if you have any questions, just send them to me, dennis.cooley@ndsu.edu. Have a great day.